Okay, so we'll be starting with software component analysis (SCA), and that is a security mechanism which falls under the shift left. We'll be walking through what SCA is, what it does, its importance, and we'll be going through a tool to demonstrate how it works. Okay. So SCA is basically it stands for software component analysis, and it looks for third party libraries which you have added in your code. So what are these third party libraries and what impact it can cause to your application security? So if you see, there was a breach with the log4j. So log4j is a logging library which is used by many applications around the globe. Uh, like the most common thing is the Apache server, which we use to build our application. That also uses this particular library to to log few features. And the impact of this breach was that all the systems which were using this third party library, all of them got compromised. So how did this happen? It was basically, if you see, like what was like the normal scenario for a log4j library, like it HTTP request is sent to the server, and that particular thing get logged. The HTML request gets logged, and whatever purpose the application uses that for, it depends on its functionality. The role of log4j was to log the request. Now what happened that some remote code execution vulnerability was introduced into this particular log4j, and some manipulations led to this particular scenario which you are seeing on the screen. So basically a LDAP payload was injected, and the attacker could send this particular crafted request to the servers which are running the log4j, which are using log4j actually as a library in their code, in their application. And when that application receives that particular malicious maliciously crafted request, then it executes it, and the execution leads to a query, and this query would connect to the attacker's control domain, and then it could lead to exfiltration and uh, other impacts to the application, like the integrity, confidentiality, both are compromised in this scenario. So the sole reason here for the breach was this particular library, which led to the entire compromise. So what whatever things you're using in your code, you don't have an idea about that, right? Like anything you can integrate. For example, if you are using Gradle to build a Java application. So in Gradle, you are adding lot of dependencies, third-party dependencies. For example, if you want to integrate Azure's Key Vault with that particular Java application, then you would be adding the Azure's library for the Key Vault in your code. And if you want some YAML parsing library, sorry, in your code, then you will be using the Snake YAML library. So there are numerous in the market which we intentionally add in our code. But what happens is that these libraries are not your code. Okay, your code, you are writing your piece of code, you are scanning them, and you are remediating the loopholes. Okay, you are actually working on your code. But these libraries, the source code is out of your reach, right? It's out of your scope. Somebody else is developing it. You are just using that particular library. So what happens is over the time, these libraries get compromised. just the way which you see on the screen right now happened with Log4j. Like over the period of time, some attackers, researchers found out this vulnerability and exploited it in the wild. So same thing could happen with the list of number of libraries which you are using in your code. So for that, we have a security mechanism termed as SCA, which works on your code in the shift left phase before your application becomes a deployment, or basically your code becomes a deployment. So that's what SCA does, scanning the third party libraries which are used in your code. Okay. So any question guys related to SCA? What SCA is?
Uh, it's clear, Max.
Okay. Okay. So moving forward, what we will be doing is same approach would be following, as it's the shift left part, right? So we'll be using the same approach where we'll be adding branch policies to the main branch, to the deployment branch, and you'll be adding your build pipeline, SCA build pipeline, to pass for pull request to be merged. So I guess that's already discussed multiple times. So we'll directly jump to the build pipeline. Now, what this pipeline is. Okay, so I have a pipeline run with me, which I just ran few minutes ago. Maybe yes. Okay. So if you see here in this pipeline, what is required, okay, and what is not. So, okay, to explain this, you need to understand the genuine flow, what it would be. Okay, so this is some Maven Authenticate. So I am using some artifacts I'll be using in my application. So this particular thing is used to fetch that. Okay, then comes the Gradle build part. This is for a Java application. Gradle build part comes into picture where you are using your Gradle file, and you are converting it into a .jar file. Okay, whatever code you have, everything you are just clubbing everything together into a .jar file, and then after that it comes your build and push to the repository. But you see, I am not doing that here in my pipeline. Okay, my goal is to just scan the third party libraries which are being used in my code. So this step, Gradle build. Okay, after this step, your tool, OWASP Dependency Check, would be able to identify the third party libraries which you are using in your code. So these two steps you should add. Okay, and once you add these two steps, then you can run your dependency check. Okay, now this was the case with the Gradle based application. Okay, now I'll just show you some front end configurations where what you need to do is, yeah, you need to just pass this step. Okay, you need to just pass this step and it will scan for third party libraries, nothing else, just one step. I need to configure this step. And for a Java based application which is using Gradle, you need to add the Gradle steps. And the reason here is because these two steps club the libraries, okay, and it creates into a jar file which the tool then scans. So uh, let's come to the tool now. Okay, what this tool asks you, okay, it asks for the scan part. Okay, like what needs to be scanned. So you need to give the path. Okay, maybe you see in example it's saying that are you gonna scan some .jar file, some directory. So what I have given is I have just given the build source directory. So whatever my agent is running on, right, and what is the source, whatever is the source directory. that directory this it will scan for. So for example, the agent has cloned the repository and it has ran these two steps and it has created a jar file already in that in the current working directory. So that exact directory I've pointed to, build source directory as a variable. So I don't need to worry upon the path. Whatever path my agent is running on, my build agent, it would be picked up and it would be scanned. Okay, and project name is up to your choice. Display name up to your choice. Then there is some exclude path. Okay, maybe some path of the code you don't want to scan for for third party dependencies. So that you can exclude here. You can add that part here. Report format you need to give HTML. I am using HTML. There are different formats, but HTML is the most simplest one. Okay, now something interesting here is the CVSS failure threshold. So what is this CVSS failure threshold? You remember like whenever we were going through the vulnerabilities from the different tools, there was a CV score to all the findings. So this is exactly the same thing. Like if my vulnerability is having a rating of 7 out of 10, then it should fail. Okay, then it should fail, and what will happen is my pipeline will also fail if my tasks fail. Okay, so same concept which we use for other tools as well. Like we are having a failure threshold, and we are extracting the reports. We are giving the scan path, and that's it. And then our pipeline is ready to scan. Okay, now another thing which we'll be seeing later. Okay, let's go to the pipeline once, and after that we'll look into this. Okay, so this pipeline ran. Okay, if you see one, two steps for the Gradle, and in the same directory, it started scanning. So these are the logs if you see, and this is a free tool, and you can add this directly. Okay, into your DevOps pipeline. You can add it as a YAML as well. You can add it as a classic pipeline, whatever suits you. Okay, so you can simply go here, so simply add it. And if you want to add it as a YAML, so if you see, you can add it as a YAML as well. Hmm. Okay, so if you see the tool is running, these are the logs of the tool. Okay, it's just scanning for different data for different databases. So it's having list of vulnerable libraries, and it compares it with that particular thing with the latest updates. Okay, and maybe something not there somewhere could not be initialized. Okay, so these are the tools logs actually which you're seeing on the screen. And at the bottom, if you see, you there's something comes which says CVSS threshold violation. Pipeline has failed. Okay, so this is what we have configured. CVSS threshold violation. But now the question is like, okay, the pipeline ran, where is the results? So results again in the artifacts, downloaded as an HTML file. I just click it, I get the results here. If you see here now, okay, if you see here now, you can see the dependency, vulnerability IDs, package, highest severity, CV count, confidence, evidence count. These are the things. So let's see one by one what are they. This thing would be same as I told you. A jar file would be scanned, right? For Gradle projects. So that's why we added those two steps. Okay, the Gradle build steps, which should be there for the build pipeline while you are intending to create a jar file and push it to the Docker file and push it to the container registry. Those those would be those would be the normal steps while you try to perform that. Okay. But in our case, we just stopped after creating the jar file because we are not concerned with the Docker files here, right? So we just stopped there. So this jar file will be scanned for the vulnerabilities, and then he is giving you the vulnerability ID exactly like what he found as vulnerable. Okay. And then the package, under which package this particular vulnerabilities was found. Okay. And then comes the severity, CV count, confidence. This is self-explanatory. So what we will do is this is a summary, right? This is a summary. Now what you can do is you can do a control F and just search for, okay, this will what maybe another shortcut I will give you. Mm, okay, there is something called high, if you see here, and there is something called medium. Okay, and then comes again high. So you see there are different vulnerabilities, right? Of different score. There is high also, there is medium also, there is low also. So you need to figure it out, like because of which vulnerabilities did your build fail. So I've given it as 7, right? So simply what you can do is you can search for medium. Okay. And if you just go with medium, you see this is 6.5. So this has not resulted in your build to fail. This is 5.5, 5.5, 5.9, 5.5 again. Under medium, nothing is coming as 7. Okay, which could have led to the build failure. So we have just gone through that. I'll just go through high now. Okay, so if you see there is one high, 8.6. So this you need to work upon. Okay, like what was this? Okay. So if you see, it's giving you the exact vulnerability ID at what this vulnerability is, published vulnerabilities. And if you just scroll up a little bit, you will see that this is the jar file which we scanned for, and this is the third party library which was included in this jar file. This is some Azure core, something is coming up here. Okay. Now there is some evidence tab as well, which you can just go through, where where it where it gives you like the sources and all, confidence, package name and all, vendor. This you can ignore actually. But the thing to be concerned here is this particular CVE. Okay. You need to check this CVE, and you need to check the score. What is the score? And you need to check the identifiers. Like what are the identifiers for this vulnerability? So you see there is something called Azure Core, Azure CLI, Azure SDK. These three things you can see here, right? So what is this exactly? Okay, so if you see like under one particular library, there could be like child libraries. Maybe that child library is vulnerable, then you need to update the parent library. And some scenarios you have just one single library, there is no parent concept. So that also you need to consider, just the thing you can see here, right? Okay, so here he's giving you the vulnerable software and versions. Okay, like versions up to excluding 2531. You see here, he's giving you the exact version which you need to update to if you want to evade this particular vulnerability. So he's giving you the fix as well. and is giving you some references. So these things you can go through, and then you can check, okay, whether you need to work upon this, whether this is really a vulnerability for you or not. Okay, so let's see one more. Okay, so this what it says is this is the Azure identity 1.81. Okay, this is something, and okay, these are the particular cryptos for that. And under evidence, we'll not go through evidence. We'll just see the identifiers here. Okay, yes. Okay, so now see here. You see one vulnerability is there, CV 2023. Then there is another vulnerability, 36415, which means that this particular library is having multiple vulnerabilities. Okay, multiple vulnerabilities are there, and if you see here, it's giving you with every vulnerability, it's giving you the vulnerable software and versions. So if you just go through this, if you just go through this one by one, and just go through the main title which says Azure Identity, okay, and let's go to every vulnerability. And if you see here, vulnerable software is Azure Identity, Azure Identity, Azure CLI versions, Azure Identity. Same thing is there, but different vulnerabilities. What does this means? That a particular library is very critical if it's having vulnerable, like multiple vulnerabilities. So maybe this won't be a risk for you, this won't be a risk for you, but this would be a risk for you. So in such scenarios, no, you, and also the base score is high, 8.8. Okay, for this particular vulnerability, it's 8.6. This one is medium, but that doesn't mean that you will ignore it because one particular vulnerability is medium. Even if a single CVE is having a high rating, then you need to work on this. So what you would be doing is you will be going to this Azure Identity 1.81 jar, and then you would be saying, okay, what is the fix for this? And if you see excluding 110 1.10.2 1.10.2, it's telling you to upgrade to that 1.10.2 version. If you just go to this particular version, yeah, if you see here, he's saying 2.5.3. So here that child and parent concept is there. You don't need to worry for this as Microsoft Azure CLI, because this comes under this particular Azure identity only. Okay, so next part comes of the suppression. So what you can suppress? What is suppress? Maybe you are going through this particular vulnerabilities, okay, and I've just moved to some other which says this is something BCPROV JDK, some jar file is there. Okay, this is some library which we are using, and this is also having one, two, three, four vulnerabilities, five vulnerabilities it's having, okay. And what you are okay, what your research says is this particular library, maybe you did some risk assessments and you found out that this particular library is, though it's having a high score, 7.7, but this is not a risk for us. It could be any reason, depending on your architecture, network architecture, your business business architecture, like the business logic architecture, or maybe this particular library is not invoked only uh, for the legit traffic for the application, or any XYZ reason. This is not a risk for you. Then what will happen is with every pipeline run, this would be flagged. You would be remediating everything, but you won't be remediating this because this is not a risk for you. Maybe you don't want this thing to be alerted in future. So You just click on suppress for this particular vulnerability. Okay, this is for a particular vulnerability. You will get a XML file. You need to just copy this XML file, and you need to place this in the root directory of the repository with the file name as SCA bypass.xml. File name you can choose of your choice, and you need to call this file in the suppression path. Okay, you see it's asking for a file when you click on the three dots, which means that it it wants that particular file here, and whatever here is whatever you have added here, you just need to copy paste here the XML. Okay, whatever you need to suppress, and in the next scan this won't be flat. This won't be flat. This will be whitelisted basically, this library. So some libraries which you couldn't upgrade, there is no upgrade available, some or the other reason, right, where you need to mute this, then you will be using this suppression thing. And again, if you see, there are there are two there are two options here, right? If you see this particular, okay, let me filter this out. It is in the summary. In the summary, it says, okay, and 1.70, this is the package, and this is the exact file path where that library lives. Okay. So if you want to suppress a particular vulnerability for this, then also this would be flat. What you need to do is you need to suppress the identifier. Okay, what were the identifiers? So if you see here, there are many libraries here. So these identifiers, what are they? They are nothing. They are but the child libraries. Child libraries for this BCPROV. So it's having some bouncy castle. This particular the all these things, no, all these things are under the same tree of BCPROV with this particular identifier. So these are the child libraries which are vulnerable. So there are two options for you. Okay, basically three options. You need to edit the source code of this particular child library, make it unvulnerable. Okay, whatever the vulnerability is, the reason, and then start using it. Okay, locally, which is practically impossible. Second thing is you need to just update this particular parent library, or hoping that the latest version won't be having vulnerabilities in all of these childs. Okay. Third option would be to suppress it. So you need to suppress every child library here. If this particular parent library is is of no use for you, like of no risk for you, basically, if then you need to suppress all the child libraries which are flagged as vulnerable. We need to use this particular suppress, and you need to add all these in a XML file here and run it, and then what will happen is this won't be flagged for you. So this is another feature for this tool to deal with false positive or the whitelisted libraries. Okay, any questions till now?
Uh, no, Mohammed, able to follow.
Yeah, from my side also clear.
Okay, okay, so so this is how you should work on your SCA, and there are links here. If you want to implement this and run this, you are having some doubts or some curiosity, you can just go through and read the docs here. And in the summary also, you will see vulnerabilities found. Vulnerability suppressed is 0 because we didn't do anything here. Vulnerable dependencies is 34. How many it scanned? It scanned 513. So you see the ratio. How many dependencies we usually use in a code which is 5513. So out of 513, 34 has been flagged as vulnerable. Now there would be some issues where you won't find a package directly in the code. Okay, for example, this Azure core. So let's search for this. This maybe you can. Okay, if I just go into the build.gradle, here is where every dependency stays. So if you see Azure, I cannot find anything related to Azure. Okay, see that's how I'm calling the libraries. Azure Security Key Vault, Azure Security Key Vault Secrets, SDK Parent. So directly when I search for it, this particular library I cannot find. But maybe see com.azure. So if I just go here, maybe I can find this. See com.azure. So you see here, if when you click here, any particular package, you will get the parent library here as well. And then you need to go here com.azure, which means that you need to fix this particular thing. This is causing that particular issue. And this particular library would be remediated once you update that particular finding. Okay, so this is one thing. Another would be this is your so everything you see, these are coming out from here. So maybe another example. Okay, I think so. Yeah, this is the simplest way to find the parent libraries. Okay, so if you see, then in our logs, this particular pipeline will fail, serious threshold violation, and then the developers and the concerned team members from the security would be notified, and then you can start working on it, remediate it, rerun it, and then assure that everything is under control for the third party libraries. Okay, so this was all about SCA pipelines, OWASP dependency check, the open source tool for the SCA. So guys, any questions? You can please go ahead.